A single candle flame 400 light-years away would still be visible to the naked human eye, if it burned bright enough in the dark of space. That is how sensitive your eyes already are to starlight. But what if every one of those points of light, all at once, simply stopped? No warning, no countdown, just silence where there used to be fire. Right now, the light hitting your eyes from the night sky left its source anywhere from 4 years ago to over 13 billion years ago. Some of what you call a star is already gone, and you are only now finding out. But this thought experiment asks something stranger. What happens if every star, everywhere, in every galaxy, extinguishes in the same instant? The first thing you would notice is nothing at all. Light already in transit keeps traveling. The sky above you tonight would look completely unchanged for years, decades, sometimes millennia, depending on the distance of the star. Proxima Centauri, the closest star to our Sun at 4.2 light-years away, would still appear to shine for over 4 years after it died. Sirius, the brightest star in our sky, would linger for 8.6 years. You could be standing under a sky already stripped of every star and have no way to know. But here is the unsettling part. The stars would not vanish altogether from your perspective. They would blink out one by one, closest first, in a slow crawl across your lifetime and the lifetimes of your descendants. A funeral procession spread across tens of thousands of years, moving outward from Earth like ripples in a pond you cannot see the edge of. And that is only the visible disappearance. The real catastrophe starts somewhere else entirely, somewhere you cannot see or photograph. It starts with heat. Every star is a furnace, holding back gravity through nuclear fusion, a war between outward pressure and inward collapse that has been raging inside the Sun for 4.6 billion years. Stop the fusion, and the war ends instantly. But the light and heat already generated does not disappear with it. Our Sun's core would take about 100,000 years to fully cool from the inside, but its effect on Earth would be immediate and brutal in a different way. Without new energy pouring out from fusion, the outer layers of the Sun would begin to contract and dim within minutes, and Earth's surface temperature would start dropping within about a week. Take a planet exactly like ours, remove its only heat source, and you get a world sliding toward absolute zero in a matter of years. Photosynthesis collapses first. Plants that depend on sunlight begin failing within days. The atmosphere itself would eventually start to freeze and fall as solid nitrogen snow, coating the ground the way frost coats a window pane, except this frost would never melt again. But losing our own star is only the beginning of the problem, because our Sun is not what holds the solar system in place. The Sun's gravity is... So what happens if every star's mass disappears along with its light? Stars anchor planets, planets anchor moons, and entire galaxies are held together by the combined gravity of billions of stars orbiting a common center. Remove the mass, and every orbit unravels at once. Planets that circled dead, dark stars would go flying outward in straight lines, drifting into the black with no sun to pull them back. Solar systems would not just go dark. They would come apart. If you have made it this far into a universe with the lights turned off, drop a like right now, because the next part of this experiment is where the scale becomes almost impossible to hold in your head. Zoom out from solar systems to galaxies, and the picture gets stranger still. The Milky Way contains an estimated 100 to 400 billion stars, all orbiting a supermassive black hole at the center called Sagittarius A star, a black hole with a mass around 4 million times that of our Sun. Stars far from the center take hundreds of millions of years to complete a single orbit. Remove every star's gravitational contribution at once, and the galaxy's spiral structure, the very shape you see in photographs stops making sense. There would be nothing left to spiral. Only the black hole at the center and a slowly expanding cloud of drifting, starless debris where a galaxy used to be. But even that black hole depends on something. It depends on stars falling into it to keep growing and glowing with the radiation of infalling matter. Cut off the supply, and even the brightest galactic centers in the universe begin to starve into true darkness within a comparatively short cosmic time frame. And this is where things become strange in a different way, because losing every star does not just change what we see. It changes what keeps existing at all. Stars are not just light bulbs in the sky. They are furnaces that manufacture almost every element heavier than hydrogen and helium. Carbon, oxygen, iron, calcium, the elements in your body and in the ground beneath your feet, were forged inside stars and scattered across space when those stars reached the ends of their lives. If every star vanished tonight, the universe would be frozen at whatever chemical composition it happened to have at that exact moment, with no future stars ever forming to create anything new. No new planets, no new elements, no new chemistry for anything resembling life to build itself from ever again. You might assume that with the stars gone, at least the raw material for a next generation would remain, drifting and waiting. But the next problem overturns that assumption completely, because stars are also the only thing preventing enormous clouds of gas and dust from simply dispersing into nothing. Without stellar winds and radiation pressure holding regions of space in a delicate balance, the vast nebulae that would normally collapse into new stars over millions of years lose the very process that shapes them. Star formation itself is a cycle that requires existing stars to seed the elements, and existing radiation to trigger new collapses and surrounding clouds. Break the cycle entirely, all at once, and you do not just lose the stars that exist. You lose the mechanism that was ever going to make more. So what does a universe like this actually look like, ultimately? Once enough time has passed for the last photon of ancient starlight to finish its journey to wherever it was headed. It looks like almost perfect blackness, broken only by the faint residual glow of decaying black holes and slowly cooling planetary remnants. No new light being generated anywhere, ever again. Just a universe of scattered dark matter, starless galaxies drifting apart from each other under the relentless expansion of space, and silence stretching outward in every direction with nothing left to interrupt it. Cosmologists studying the far future of our actual universe describe an era sometimes called the degenerate era, when ordinary star formation has already ended naturally, and only the slow decay of stellar remnants provides any light at all. This thought experiment simply drags that far future backward into tonight. There is something almost meditative in sitting with this idea rather than only fearing it. Every star you have ever looked up at is finite. Every one of them will eventually run out of fuel on its own timeline, whether that takes millions of years or trillions. The instantaneous version of this event is impossible. Physics does not allow every star to fail on cue. But the slow version, the one already written into the future of the actual universe you live in, is not a hypothetical at all. It is simply waiting, patiently, on a timescale too vast for a single human mind to feel the weight of. That gap between the impossible instant version and the very real slow version is worth sitting with, because it means the sky above you tonight, however calm and permanent it looks, is quietly already in motion toward exactly the ending this entire thought experiment describes. If this kind of question keeps you up thinking about the sky differently, subscribe before the universe finishes what it already started, and go check the next video in this series. For anyone not ready to leave the dark just yet.